Hello students, welcome back. So we are doing exercise 21E from trigonometry, isn't it? So in our previous videos we have completed till question number 1 of this exercise, and today we'll start from question number 2 onward. Okay, so let's begin this question. So in question number 2 we have two conditions. Condition 1 is sin A plus cos A equals to P, and the second condition is sec A plus cosec A equals to Q. So these two are the given conditions, and we are asked to prove this. Q into P square minus 1 equals to 2P. So let's begin. Let's copy the left hand side of this equation. LHS equals to Q into P square minus 1. We are going to use this and prove this equals to 2P. Okay. So now let us put the value of Q. What is Q? Q is sec A plus cosec A, isn't it? Q is sec A plus cosec A. So instead of Q I write sec A plus cosec A. Now what is P? P means sin A plus cos A. So P means sin A plus cos A. Sin A plus cos A. This is P. P means sin A plus cos A, but we have P square here, so we need to put square here also. Minus 1. Okay. Now let's copy this as it is. Sec A plus cosec A. Let me put the simple bracket here. Now here you can see A plus B whole square. Let's assume this sin A as A and cos A as B. Okay, so A plus B whole square means A square plus B square plus 2AB, isn't it? A square plus B square plus 2AB. Okay, minus 1. This minus 1 comes here. So A plus B whole square. Sin A is considered as A and cos A is considered as B. So A plus B whole square means A square plus B square plus 2AB. This minus 1 is this minus 1. Okay. Now let's copy this as it is. Sec A plus cosec A. Now we know that sin square A plus cos square A means 1, isn't it? So this is 1. Instead of sin square A plus cos square A, we can write 1 plus this 2 sin A into cos A minus 1. We have minus 1 here, isn't it? So let's cancel this plus 1 and minus 1, because plus 1 and minus 1 becomes 0. Now we have sec A plus cosec A, bracket means into, okay, sec A plus cosec A into 2 sin A cos A, isn't it? We must multiply this 2 sin A cos A with sec A plus cosec A, because we have bracket sign, bracket means into. So 2 sin A cos A into sec A is 2 sin A cos A into sec A, isn't it? 2 sin A cos A into sec A. Plus sign comes here. Now 2 sin A cos A into cosec A means 2 sin A cos A into cosec A. I hope you are getting me. Now let's take this 2 common out. Okay, we have 2 and 2 here. 2 is taken common. Now you know that cos A into sec A means 1, isn't it? You know that cos theta equals to 1 upon sec theta. So if you cross multiply this, cos theta into sec theta equals to 1. Cos theta into sec theta means 1, isn't it? Because cos and sec are the reciprocal of each other. So similarly, sine and cosec are the reciprocal of each other. Okay, this sin A comes here, sin A, this sin A we write as it is. Now cos A into sec A means 1, so sin A into 1 is sin A, isn't it? Cos A into sec A is 1, so sin A into 1 becomes sin A, plus here we took out this 2 common outside. Now cos A remains here, cos A. Now sin A into cosec A. This sin A into cosec A. Sin A into cosec A means 1, isn't it? Sin A into cosec A means 1. So cos A into 1 is cos A. So ultimately we have 2 into sin A plus cos A. So 2 into sin A plus cos A means sin A plus cos A means P. Sin A plus cos A means P. So this 2 we copy as it is. Okay. This 2 we copy as it is. Now sin A plus cos A means P, isn't it? Sin A plus cos A means P. So we write P. This equals to RHS, isn't it? We have 2P in the right hand side. So we got 2P. I hope you got this. Now let us do question number 3. Okay, now let us do the next question. This is question number 3 from exercise 21E. So we are given two conditions here also. X equals to A cos theta and Y equals to B cot theta, isn't it? And we are asked to prove this. A square upon X square minus B square upon Y square equals to 1. So let's copy the left hand side of that equation. A square upon X square minus B square upon Y square. Okay. LHS equals to LHS means left hand side, isn't it? A square upon X square minus B square upon Y square. Now let us put the value of X and Y. Okay. So A square we copy as it is. A square is in the numerator. We copy as it is. In the denominator we have X square, and we know the value of X is A cos theta. X is A cos theta means X square means A square cos square theta, isn't it? Because X is A cos theta, X is A cos theta, and X square means this is the value of X, so X square means whole thing square. Now this square applies to both A and cos theta because both of these numbers are within the bracket, isn't it? So A square is A square and cos square theta is cos square theta. The same thing I wrote here, isn't it? Okay. Now minus B square we copy as it is in the numerator, and in the denominator we have Y square. What is the value of Y? Y is B cot theta. So Y square means B square cot square theta, isn't it? So let's cancel this A square and A square from the numerator and the denominator. Similarly, we can cancel this B square and B square. So we have 1 upon cos square theta here, 1 upon cos square theta, isn't it? So cos theta and sec theta are reciprocal of each other, we know that. So if you take this cos theta to the numerator, it becomes sec square theta. Sec square theta. Cos square theta, if you take this number to the numerator, becomes sec square theta. Similarly, minus, this minus comes here. Cot square theta and tan theta are reciprocal of each other. So if you take this cot square theta to the numerator, it becomes tan square theta. Tan square theta, isn't it? And we know the formula, sec square theta minus tan square theta is always equals to 1 if the angles are same. Okay, angles are same, theta and theta, or A or A. If the angles are same, then sec square theta minus tan square theta equals to 1. This equals to RHS, isn't it? Hence proved. RHS. So this is the answer for question number 3. Now let us do question number 4. Okay. Question number 4. Okay. From exercise 21E, we have sec A plus tan A equals to P, and we are asked to prove sin A equals to P square minus 1 upon P square plus 1. So let's use this right hand side of this equation and prove this equals to left hand side, that is sin A. Okay. So RHS equals to, we have P square minus 1 upon P square plus 1. So this can be written as, so we put the value of P. What is P? P is sec A plus tan A, isn't it? Sec A plus tan A is P. So P squared means sec A plus tan A whole squared. Sec A plus tan A. This is P. This is P. Sec A plus tan A is P. So P squared means we must square this. Minus 1. Minus 1. What is 1? 1 is sec square A minus tan square A, isn't it? Sec square A minus tan square A can be written as 1. Sec square theta minus tan square theta is always 1. So minus 1, we have minus 1 here, this minus comes here, and 1 means sec square a minus tan square a, okay, minus tan square a. We can write this in the denominator. Same thing, p square means sec a plus tan a whole square. Sec a plus tan a, this is p, and p square means this whole square plus, we have plus here, this plus comes here, and 1 means sec square theta minus tan square theta is 1, so instead of 1 I write sec square a minus tan square a, isn't it? So let's copy this as it is, okay? Sec a plus tan a whole square minus, now this is a squared minus b squared, okay? Sec a, let's assume this sec a as a and tan a as b. So a squared minus b squared means a plus b into a minus b, isn't it? So a plus b into a minus b. I hope you are getting me. Sec square a is a, sec a is a and tan a is b. So sec square a is a square minus tan square a is b square. A square minus b square is a plus b into a minus b. Okay. The same thing we do in the denominator as well. Let's copy sec a plus tan a as it is. Sec a plus tan a whole square plus, here also we have sec square a minus tan square a, that means a plus b into a minus b. A plus b into a minus b, isn't it? Now we have sec a plus tan a whole square here, and we have sec a plus tan a here also. Let's take sec a plus tan a common outside. Sec a plus tan a can be taken common, okay? Now what remains within the bracket? Sec a plus tan a whole square, isn't it? 1 sec a plus tan a is taken outside, so still sec a plus tan a remains within the bracket. Sec a plus tan a, because sec a plus tan a into sec a plus tan a gives us sec a plus tan a whole square. So this minus sign comes here. This sec a plus tan a is taken common outside, so this sec a minus tan a remains within the bracket. Sec a minus tan a remains within the bracket, isn't it? And in the denominator we copy, sec a plus tan a, here also we can take the common. Sec a plus tan a common, sec a plus tan a is taken common, okay? Here we have sec a plus tan a whole squared, so 1 sec a plus tan a is taken common outside, still sec a plus tan a remains within the bracket, isn't it? Plus tan a. Sec a plus tan a into sec a plus tan a gives us sec a plus tan a whole squared. Now this plus sign comes here. Sec a plus tan a is taken common outside, this sec a minus tan a remains within the bracket. Sec a minus tan a, okay? This sec a plus tan a, this sec a plus tan a from the numerator and denominator can be cancelled, isn't it? So we have sec a plus tan a here, sec a plus tan a, sec a, let me continue this here, okay? This sec a plus tan a, sec a plus tan a, this sec a plus tan a, minus into plus, minus sec a, isn't it? Minus into minus plus tan a. In the denominator we have sec a plus tan a, sec a plus tan a plus sec a minus tan a, sec a minus tan a, isn't it? So this plus sec a and minus sec a can be cancelled, plus tan a minus tan a can be cancelled. So in the numerator we have tan A plus tan A, that is 2 tan A, 2 tan A, isn't it? Tan A plus tan A, 2 tan A. In the denominator we have sec A plus sec A, 2 sec A. So this 2 and 2 can be cancelled. Tan A means sin A by, tan A means sin A by cos A, isn't it? Tan A means sin A by cos A. So this sec A when goes to the numerator becomes cos A. Now this cos A and cos A can be cancelled. We have sin A left. So this is the answer, sin, isn't it? Sin A is in the left hand side. Hence this equals to LHS, and it's proved. I hope you got this. Now let us do question number 5, okay? Okay, now let us do question number 5. We have tan A equals to n tan B and sin A equals to m sin B. These two are the given conditions, and we are asked to prove cos square A equals to m square minus 1 upon n square minus 1, isn't it? So let's do this. First, let us simplify this, okay? Since tan A equals to n tan B, that means n equals to tan A remains here, isn't it? This tan B goes to the denominator, tan B. N equals to tan A, this tan B is cross multiplied and taken to the denominator of tan A, okay? Tan A goes to the denominator, n remains in the right hand side, and tan B goes to the denominator. So n equals to tan A upon tan B, isn't it? Or you can write as n equals to tan A means sin A by cos A, and tan B means sin B by cos B, isn't it? Sin B by cos B. This cos B goes to the numerator. Okay? Sin B upon cos B. This cos B goes to the numerator. So n equals to sin A into cos B upon cos A into sin B. Okay? Here we have sin A equals to m sin B. That means m equals to sin A remains here. This sin B goes down to the denominator of sin A by cross multiplication. Okay? Sin A upon sin B. I hope you are getting me. This sin B goes to the denominator of sin A by cross multiplication. So we have n equals to this and m equals to this, isn't it? Now we are going to use the right hand side of this equation and prove this equals to cos square A. Okay? So LHS, not LHS, RHS. RHS equals to, we have m square minus 1 upon n square minus 1. So let us put the value of m and n. What is m? M is sin A upon sin B. That is sin square A upon sin square B, isn't it? M square. M means this. So m square means we must square this. So whole square means sin A by sin B. Whole square means this square is applied to both A and B. I mean both the numerator and the denominator, isn't it? So you can put the sin square A and upon sin square B. You can put this square individually to the numerator and the denominator. Okay? So m square means sin square A upon sin square B minus 1. And in the denominator we have n square. What is n? N is whole thing square, isn't it? N squared means this whole thing squared. Okay? Sin square A cos square B upon cos square A sin square B. N squared means sin square A into cos square B upon, okay, cos square A into sin square B minus 1. Let me write this minus properly, minus 1. Now let's take the LCM here. We have sin square B and 1. The LCM will be sin square B. Sin square B. So 1 into sin square A is sin square A minus sin square B into 1 is sin square B whole upon we have 1 here also. Cos square A and sin square B into 1. Cos square A, sin square B into 1. The LCM will be cos square A, cos square A, sin square B, and cos square A, sin square B, and 1 into cos sin square A, cos square B, sin square A into cos square B, minus comes here, cos square A, sin square B into 1, cos square A, sin square B. Okay, 1 into this is this, sin square A, cos square B, this into 1, cos square A, sin square B. Now you can see sin square B in the denominator, sin square B, and here also sin square B in the denominator. You can cancel this, isn't it? So this cos square A goes to the numerator now. Let me continue here. This cos square A goes to the numerator here. This equals to cos square A into sin square A minus sin square B, sin square A minus sin square B, whole upon, in the denominator we have sin square A, cos square B, minus cos square A, sin square B, isn't it? Sin square A, cos square B, cos square B, minus cos square A into sin square B, cos square A into sin square B. Sin square B means 1 minus cos square B. Sin square B means 1 minus cos square B, because sin square B plus cos square B gives us 1. So sin square B can be written as 1 remains here. This plus cos square B goes to the right hand side, becomes minus cos square B. So 1 minus cos square B, instead of sin square B you can write 1 minus cos square B. So here we have cos square A into sin square B. This is cos square A, okay. Instead of this sin square B, I can write 1 minus cos square B. Instead of this sin square B, I can write 1 minus cos square B. Okay. I hope you are getting me. Now in the numerator we have cos square A into sin square A minus sin square B means 1 minus cos square B. This is B. Angle should be same, okay. Sin square B means 1 minus cos square B. This is curly bracket, okay. Here sin square A into cos square B minus cos square A into 1 minus cos square A, okay, minus into minus plus cos square A into cos square B, cos square A, cos square B. So you can take cos square B common from these two numbers, this and this. Cos square B can be taken common, okay. In the numerator we have cos square A, here sin square A, cos square A into sin square A, minus into plus, minus 1, minus into minus, plus cos square B, minus into plus, minus 1, minus into minus, plus cos square B. And in the denominator we have, let's take cos square B common from this two, cos square B is taken common, okay. Within the bracket remains sin square A, cos square B is taken common. So here also cos square B is taken common. Cos square B is taken common. This sin square A remains within the bracket. This cos square B is taken common. This cos square A remains within the bracket. Plus cos square A, isn't it? So minus cos square A, this minus cos square A remains outside the bracket. Okay. Now this means 1, isn't it? Sin square A plus cos square A means 1. So we copy the numerator as it is, cos square A into sin square A minus 1 plus cos square B, and in the denominator we have cos square B into 1, sin square A plus cos square A. Angles are same. Please see here, the angles are same. Sin square A plus cos square A, this means 1. So cos square B into 1 is cos square B, isn't it? Cos square B into 1 is cos square B. So this minus comes here, and this is minus cos square A, isn't it? So we have cos square A in the numerator, cos square A. This is sin square A minus 1 plus cos square B, isn't it? So in the denominator we have cos square B minus cos square A means 1 minus sin square A. Cos square A can be written as 1 minus sin square A, isn't it? So this is cos square A. Let me continue this here, okay? Here. This gives us cos square A into sin square A minus 1 plus cos square B. Sin square A minus 1 plus cos square B, isn't it? And in the denominator we have cos square B minus into plus 1, that is minus 1, and minus into minus plus sin square A. Now you can see this sin square A is plus, this sin square A is plus, this one is minus, this one is minus, cos square B is plus, so this cos square B is plus. So these two numbers are similar to each other. One is in the numerator and one is in the denominator, isn't it? We can cancel that. So now remains cos square A. So this is equals to LHS, hence proved. Okay, this question is not a difficult one but a lengthy one, isn't it? A little bit tedious, a little bit boring, isn't it? Anyway, you have to do it. So let's move on to question number 6. Question number 1 of 6. If 2 sin A minus 1 equals to 0, this is the given condition. We are asked to prove sin 3A equals to 3 sin A minus 4 sin cube A. Okay, so we are asked to prove this equation. First, the given condition is this. We are asked to prove this. So let's do this. Since 2 sin A minus 1 equals to 0, this is the given condition, or sin A equals to this minus 1, if you take to the right hand side, becomes plus 1. Minus 1 when transposed to the right hand side becomes plus 1. This 2 goes to the denominator by cross multiplication, isn't it? 2 into sin A. So this into number goes to the denominator. Minus number goes to the plus. Plus becomes minus. Minus becomes plus. Into becomes divide. Divide becomes into, isn't it? I hope you know this. So we have sin A equals to 1 upon 2. This means, or sin A equals to sin 30 degree. Sin 30 degree means half, isn't it? Sin 30, the value of sin 30 degree is 1 upon 2. So sin A equals to sin 30. Now we cannot cancel this sign, okay? Sin, cos, tan, cot, sec, cosec are trigonometrical identities. So identities should not be cancelled like this. So we can leave this identity, sin, and we can write A equals to 30 degree. What is the value of A? We got the value of A is 30 degree. Now let's check out the left hand side first and then right hand side, okay? LHS of the equation, sin 3A, okay? This means sin 3 into A. What is A? A is 30 degree. Sin 3A means sin 3 into 30. So sin 3 3s are 90. 3 3s are 9. 3 0s are 0. Sin 90. Sin 90 means 1. So LHS equals to 1. Now let's check out the RHS. Okay, RHS. Right hand side we have 3 sin A minus 4 sin cube A, isn't it? So 3, what is the value of sin A? Sin A is 30 degree. 30 degree minus 4 sin cube A is 30 degree. 30 degree, isn't it? So 3 into sin 30 means 1 upon 2. Sin 30 means 1 upon 2. 3 into 1 upon 2. Minus 4. Sin 30 means 1 upon 2. But we have sin cubed. So we must put cube here. So 3 ones are 3 upon 2. 3 ones are 3. In the denominator we have 2. Minus 4. So 1 cubed is 1. Isn't it? 1 cubed is 1. So minus into plus, minus, minus into plus, minus, 4 ones are 4, and 2 cubed is 8. What is 2 cubed? 2 cubed is 8. 2 into 2 into 2. 2 multiplied 3 times is 8, isn't it? So 4 ones are 4, 4 twos are 8. So 3 minus 1 is 2. 3 minus 1 is 2 upon 2. So this is 1, isn't it? So LHS is 1 and RHS is 1. Hence proved. Hence LHS equal to RHS equals to 1. Okay. Let us do question number 2 of 6. Okay. Here we have 4 cos square A minus 3 equals to 0. This is the given condition, and we are asked to prove cos 3A equals to 4 cos cube A minus 3 cos A, isn't it? So let us write the given condition first. Since 4 cos square A minus 3 equals to 0, isn't it? Or cos square A equals to, let us take this minus 3 to the right hand side, becomes plus 3, isn't it? Minus 3 when taken to the right hand side becomes plus 3. This is equal to, okay? This is equal to minus 3 becomes plus 3. This 4 goes to the denominator, isn't it? Now, or cos A equals to this square, when you take to the right hand side, becomes square root of 3 upon 4. This square becomes square root. So, or cos A equals to square root of 3 is root 3, isn't it? So square root of 4 is 2, root 3 by 2, isn't it? Or square root of 4 is root under 2 into 2, 2 to the 4. So we make the pair and take 2 common outside. Okay? So 3 has no pair, so 3 remains within the bracket. Cos A equals to, so root 3 upon 2 means cos 30 degree, isn't it? Cos 30 degree is root 3 upon 2. So we cannot cancel this cos and cos, but we can leave this cos and cos from both the sides. So A equals to 30 degree. So we have found the value of angle A. Angle A equals to 30 degree. Okay. Now let us prove the equation. Let's take left hand side first. LHS equals to cos 3A. Cos 3A. So cos of angle. What is 3? What is 3? 3 is 3. 3 is the number, isn't it? So what is A? A is 30 degree. A is 30 degree. So cos 3 3 is 9. Cos 90 degree. What is the value of cos 90 degree? Cos 90 means 0, isn't it? Value of cos 90 is 0. Now let us write the right hand side also. RHS. RHS equals to 4 cos cube A minus 3 cos A. So this is 4 cos A. What is cos A? A is 30 degree. So 30 means, what is the value of cos 30? Root 3 by 2, isn't it? Cos 30 means root 3 by 2. Root 3 by 2 whole cubed minus 3 cos A. Cos A means root 3 by 2. Okay. So we have 4 into root 3 cube means root 3 3 root 3, okay? Root 3 cubed means 3 root 3. Root 3 into root 3 into root 3. Root 3 cubed means root 3 into root 3 into root 3. So root 3 into root 3 is, root 3 into root 3 is 3, and this root 3 remains within the root. 3 root 3. Root 3 cubed means 3 root 3. Similarly, 2 cubed means 2 into 2 into 2, that is 8, minus 3 root 3 upon 2. So 4 1s are 4, 4 2s are 8. 3 root 3 upon 2, 3 root, this is 3 root 3, 3 root 3 upon 2, minus 3 root 3 upon 2. So same number, 3 root 3 upon 2, 3 root 3 upon 2, one is negative and this number is positive, so this number minus this number gives us 0. Therefore, LHS is also equal to 0 and RHS is also equal to 0. Hence, LHS equal to RHS equals to 0. Okay, this is proved. Thank you so much for watching this video. We'll continue the remaining question in the next video. Okay.